Morning. How's everyone? Wide awake? Yeah, nice early start today. Welcome to our session. This is the operating the Microsoft Cloud Platform System. Can I ask how many of you know what CPS is? Okay, how many went to the overview yesterday? Got a bit of background? Okay, great. So I'm Daniel Savage. I'm a lead PM working on the Cloud Platform System, presenting you today with my esteemed colleagues, Justin and Thomas. We're going to take you through really once a CPS, converged solution, arrives, really what it takes to actually operate that rack. So we're going to spend our time this morning. I'm going to talk a little bit, just recap some of the information Vijay talked about yesterday on why we do converged solutions, why it's important, the things that you need to understand. I'll briefly just recap on the architecture, because that really does frame the discussion of the operational tasks that we will talk about. Then we'll go into the three main areas that we think that are important for you to understand and what it means to operate CPS. First of all is monitoring. So we'll take you through what it means to understand the health of a CPS rack, what it means on a daily basis to understand and keep that thing running. Justin's then going to come up and talk about automation. So we'll really look at the administrative tasks that you would do on a daily basis and show you how we've automated some of these tasks to make it easier and to save you time in running CPS. And then lastly, Thomas will come up and talk about backup and disaster recovery. Sound good? Okay. So let's just start and talk about why converged solutions and why we produced a system called CPS. So really when we start thinking about what it means for customers to build private clouds, there's really several options. And these options are based on the consideration of whether you want ultimate flexibility or you're looking for to get a project up and running faster. Now, if you start all the way on the right, on DIY, this means that you're building up the system yourself. You have ultimate control over all the configuration that you set within the system. But obviously that takes time to do. It takes time to validate, and it takes time to configure. But you actually have the ultimate control over that because you're the one who configured it. On the right-hand side, if you're looking for speed to market, you're looking for something that reduces the burden on the IT admin, we have a converged system. So the converged system that we offer through Microsoft, we have two. We have CPS, which is our infrastructure as a service solution, the one that we're here talking about today. And another one you may have heard of, the Analytics Platform System, or sometimes called the Parallel Data Warehouse. Our data platform is a converged system. So you've got the two polar ends there. And in the middle, we've got a fast track program. Now, if you know what our fast track is, that's our reference architecture, where we provide out to OEMs and solution partners the guidance on how they can pre-configure and pre-build solutions for you. Again, it helps kind of that speed of deployment and getting things to market. But why are integrated systems important? Vijay showed this slide yesterday and really drilled in a couple of data points around the reduction in downtime. Now, this is data. This isn't our data. It's data gathered from IDC. So when people, and there's a lot of people trying to choose converged systems, these are some of the data points that the data gathered for them. First of all, like a 97.2% reduction in downtime when you're buying a pre-configured system that has been validated end-to-end. The two that I really want to talk about today is really this improved IT staff productivity. Because, and we will show you this through the demos, because we've done a lot of the validation before the systems arrive, we know how the system works. We're able to configure it in such a way and provide you things like automation that really takes out a lot of those daily tasks that you would do in running your own private cloud infrastructure. So this is where we see this 58.4% improvement in that staff productivity when using convergent systems. And ultimately the knock-on effect of that is your reduction in your IT infrastructure costs, particularly your day-to-day running costs of running a converged solution. So let's take another look at CPS. So how many have been down to the booth and actually seen the rack? Okay, if you haven't been there, I'd advise you to go down there. We have two racks set up in the expo hall. You can actually, there's a picture of it here. It looks exactly like that. The one thing you can go see the back of the rack, and you can see all the cabling work we've done in there. Great to go get yourself a picture with that. We've got a lot of people coming by and doing that. But what is a rack? So one rack consists of a set of compute cores. Just expand that out. So one rack consists of a set of compute cores. So we have 32 Hyper-V hosts. which offer up 512 cores and 8 terabytes of RAM. There's 282 terabytes of usable storage, which is split between running for primary workloads and for the backup system. Included in the rack is the networking, so the aggregate and the management switches that plumb everything together. And then at the bottom we have 4 file servers. These are the Dell PowerEdge R620s, okay, that sit on top of the 4 JBODs that provide the storage to the system. And then logically, sorry, just to say, this is the CPS system scales. This is a single rack, and it scales up to 4 racks. So you can have a maximum of 4 racks within a stamp. So you take those numbers and multiply them up by 4, and you see the scale of the system that can be supported. So logically, how is the system broken up? So on the first rack, we logically break up the system into 4 main cluster groups. Okay, the first one being on the first rack, we have the management host group. This management host group is what runs the management software and services that actually provide the private cloud and allow you to operate the system. We have an edge cluster. This provides the networking connectivity in and between the racks. And then the compute cluster, obviously, which is what serves up the workloads, and then the storage host group. Now, as we expand this out across racks, as I said, we can go up to 4 racks within a system. You see that we continue the host groups for storage, cluster, and edge across the 4 racks. But the management cluster only exists within the first rack. So we take up 6 hosts, and I'll talk a little bit more about what's in that management cluster in a second. We take up 6 hosts for the management cluster. But that management cluster on the first rack is scaled accordingly so that when you add additional racks, you don't need to expand out your management footprint. So it comes ready with the first rack, so you can scale without having to change the infrastructure that actually runs the private cloud. Okay, so let's take a closer look at that management cluster. So on the management cluster, as I said, we have a 6-node Hyper-V cluster, runs about 32 VMs. All of the VMs are deployed as highly available, so that the VMs themselves are highly available. And we also use the application for the various applications, use their scale-out or scale-up architecture to make them highly available at the application level. So you see here we have VMM. So we have 2 instances of VMM deployed for high availability. OM, Operations Manager, 3 instances of Operations Manager to provide the redundancy there. 4 console machines. These are the machines that you connect to do your administration. We have a SQL guest cluster of 4 VMs that supports the databases that run all the System Center and the Windows Azure Pack components. We obviously have Windows Azure Pack itself. We have 2 VMs there that provide the outbound connectivity for the self-service portal. We have a DPM server for backing up the management cluster. And we have things, and we have WDS and WSUS for patching, and Justin will talk a little bit about that in a second. The triangle there for AD, DNS, these are the only ones that aren't deployed as highly available VMs. They're deployed as single instance. And that's so we ensure that we manage the circular dependency between AD and the storage coming up. So these 3 machines, you have AD, DNS on all 3, and they use local hard disks. So they're not connected to the storage, so that's why they're configured in that way. Make sense? Okay, so here's really what we want to talk about today. So the management services that are provided in the context of the system. So it starts with configure and deploy. And the configure and deploy service is Virtual Machine Manager. And the Virtual Machine Manager is used for when you have to configure additional capacity, like adding a rack, or checking out whether the VMs are actually running the management infrastructure. You have the Service Administration Portal. So this is the Windows Azure portal that allows an administrator to create plans for the self-service users to consume. We have DPM, which does the backup for the management server and for the tenant machines. We have Operations Manager for monitoring. And we have a set of automation that Justin will take you through, which is some custom work that we've done to allow you to do patching and update. And then we do, as the stamp does come with the ability to attach it to Azure Site Recovery to do DR. Now what we're going to talk about today, I'm just going to highlight the ones that we're going to demonstrate to do today as we kind of walk through these various services. We're going to go through, as I said, monitoring, automation, backup, and DR. So let's talk a little bit about monitoring. So when we set about building the system, we had some goals. And really what we're trying to do is we're trying to deliver a system that kind of takes the burden out of kind of setting up the system center components, okay, and allowing you to kind of get on with the business of running your IT. So we set aside these goals. The first thing we want to be able to do is make sure everything is monitored by default. So we deploy and we configure all the infrastructure agents when the system is actually deployed. So through the factory install process, the agents get installed, and then we import all the required management packs and configure them, and then we do configuration of things like connecting Operations Manager to VMM, all automated. You don't have to worry about that. The next thing we wanted to do is make sure we provide current, actionable health state of everything that's logically in the system. And the key word there is actionable. How many of you have used Operations Manager before? Find it noisy? Okay. I hear you. I used to work on Operations Manager for a long time. So this is kind of a very, very clear goal, is when we set out to build CPS, actionable alerts. And we worked with a lot of the management pack teams to go through some of the alerts they were generating and really just fine-tune them to make sure that when an admin gets an alert, he knows what to do with it, which is the third point there. And then secondly, during maintenance, right? We want to be able to ensure that if we're doing patching, for example, that we don't get a storm of alerts within the system. So we want to provide not just the touch points of monitoring, but the touch points across the administration task by using things like maintenance mode. So what did we do? So the first thing that we took on is we did integrated testing. So this was actually quite an interesting exercise for us. So what normally happens is a team, like a server all working in engineering, would go develop their management pack. And they would test their management pack, so the AD team would go and test their management pack on AD. Or the WSUS team would go test their management pack, and they do a good job of that. But what happens is when you bring all these things together, you get some interesting things happen, as you know if you're working with Operations Manager. Because if you get something like, say, a storage alert, you may get 6 different management packs all creating an alert around the same thing. So when we put it into the integrated testing environment, we're able to kind of fine-tune across all the management packs to be able to reduce that noise. And obviously we understand that some management packs can be noisy, and we found a lot of bugs on some of these management packs that kind of not just improved CPS, but improved the management packs out there as well. And the second point there is understanding kind of the logical structure of infrastructure to be able to understand fabric health is difficult. You know, with so many moving parts in the system and you bring it all together, really kind of understanding when something is broken and what you need to fix, there's a lot of effort involved in doing that. So we wanted to take that on in our integrated and testing environment so you don't have to worry about that when you consume a system like CPS. So we tuned the management packs. And then the next thing we wanted to do was really kind of land visualizations, which I'll show you in a second, that really kind of logically, take that slide where I showed you the logical look of the system, really provide you that in a monitoring view. So you can go straight to that monitoring view and understand whether or not your CPS rack is running healthy or not. So what did we end up with? So we eliminated the need for you to have to tune the management packs in the CPS system. We reduced the time involved in investigating issues and looking at noisy alerts. And we believe we decreased the time to ensure that we have effective monitoring. So what do we monitor? So first of all, we monitor the management cluster, which is all hosts and all the VMs that run on that management infrastructure. We manage, and that's from a kind of fabric level, is the VM up and running. We monitor all the management software components, so Windows, System Center, WAP, AD. We monitor the compute and storage clusters, all the hosts and VMs supporting the WAP tenant portal, and we also monitor storage spaces as well. You may have seen that last week we released a standalone management pack for storage spaces. So if you are kind of doing that configuration on your own, you can monitor that in OM. This management pack was incepted within CPS. So that was the first place it was developed and tested. So we're hoping you get a management pack that is kind of validated very well. The edge cluster, all hosting VMs, the multi-tenant remote access service, and then ultimately the hardware. So we work with Dell to make sure that we bring in their Open Manage agent and their management pack so we get that view into the hardware. So from the servers, the switches, the JBODs, the HBA adapters, and the load balancers as well. So we want to provide that holistic view and bring it all together. So with that, enough talking. Let me show you what that looks like. Switch over here. Okay. Everyone see that okay? Okay. So this is the starting point. So here we are in Operations Manager. If you're familiar with Operations Manager, I've just expanded that out. You see we got all the management packs I talked about listed in here. And what we did is we created our own, let me see if I can. We created our own CPS management pack that contains a set of dashboards. Now this is the primary dashboard, and this is like the first view that you would expect people to kind of be looking at to understand the health of the CPS system. Let me ask a quick question. How many, so we brought these racks over from Redmond. They arrived last week. They were plugged in last Thursday, Friday. They've been kind of they're running in the expo hall. They're running the workloads, all the demos there. If you were to guess, on average, how many alerts are generated a day from that CPS system, what would you say? Throw out a number. 200? 50? 2? That's a good one. So actually, and most of these are Thomas's fault, by the way, there's only been about 7 alerts generated a day. Now, if you know Operations Manager, 7 alerts is a pretty kind of small number and something that really kind of allows you to work through that. So we see a system that's pretty healthy. It's running, it's well tuned. We have some critical alerts there, but they're really for Thomas's demo. He's going to show you that a little bit later. We have some warnings. The system is completely redundant and fault tolerant. We have some disk issues in the rack. When the rack arrived, one of the disks was kind of in a bad state. We did bring new disks to kind of put them in and rebuild the pool, but we wanted to leave them to show you the alerts associated with when a disk goes bad, and the fact that the system's still running tells you that it's redundant. So this is the first view. Then we added a set of other dashboards that really look at these logical components. So very similar views. I'll go to the management cluster dashboard. This kind of details out all the software components, all the Windows computers that support that, and then we see the list of alerts. And these are all contextually driven, so as I click through these things, the alerts will change and update. Then we have the storage health. Again, these are all custom dashboards, so here we see all the file shares. Again, we have these disk warnings I talked about, but the system's running, that's why they're warnings and not critical. We have the capacity of all the file shares. So add all these bytes up, you get 282 terabytes across all these file shares. We have the 4 storage nodes, and then the storage pools, the spaces pools that sit on top of them. Now that's obviously what we've done custom. I think the key takeaway there is just think about the noise reduction we've done there. But obviously this is all backed by the standard management pack. So if you want to go down and look at a particular thing, you could drill into a particular management pack. So for example, the VMM management pack added a while ago the ability to kind of look at the particular hosts and their status. So the VM host dashboard. Let that come up. It's coming. This is enumerating all the 32 hosts and gathering a set of performance metrics from it, like the number of VMs and their capacity. So you see here, this is the look on the system. You get if you click through the hosts, you get the VMs that are running on them represented by this green square. So this is just the standard VMM MP, as with the other MPs, so you can kind of drill in and get further information about the system. And then let's have a quick look at hardware. So as I said, we've integrated all the Dell monitoring. So here I can go look at the Dell monitoring and look at the servers. Let me bring this up. And all the hardware's running healthy. We can kind of drill down to the clusters and to the individual servers. And you'll see here that we monitor. We have the sensors running for the memory, the temperature, the power supply. That's all monitored within the system. And if an alert goes off for one of these, then you're going to get a very actionable alert of what you need to go and do. So let's actually let's go break some stuff. Just to kind of show you what we get. What I'm going to do is I'm just going to kill a service here. Hang on, let me do this. Okay. I'm going to go to VMM and power off. Ooh. And what we should see, if I go back here, we should see here in a second the alerts for those two issues I caused. Anytime now. Let's see. I'm going to wait for a polling interval here. All right, I'll come back to that. What I wanted to show you, get an alert, but then I was going to fix the state, and the alert's actually resolved. So as the system heals itself, the alerts will go away, so you don't have to take action on them. Just check they're not coming up. Okay, we'll come back to that. So that's the monitoring in the system. I think the key takeaways is that we've done a lot of those heavy lifting that a lot of SCOM admins do. We've taken care of tuning the management packs. We've built visualizations that allow you to really understand. And then we've made sure that when we do generate alerts, there's knowledge and kind of actions in there so you can really kind of fix problems and get to root cause. And then particularly for the hardware, when a disk goes bad, for example, you get the particular disk so you can make the call to Microsoft support to be able to arrange a disk that can be replaced within the system. So that's monitoring. I'm going to switch back. It's going to come. All right. I'm going to switch back to the deck, and I'm going to ask Justin to come up and talk about automation.
Thanks, Dan.
Thanks, Justin.
Thank you. All right, folks. Good morning, everyone. My name is Justin Incarnato. I'm a program manager on the Cloud Platform Solutions team. Work with Daniel and Thomas quite a bit, building out the solutions. I want to talk to you guys today about automation. So we're going to talk about a few things. We'll talk about some of the repetitive tasks that we wanted to automate in CPS. We've got a lot of passwords that we can cycle through. You guys have set up System Center before. You guys have set up SQL before. We want to make sure that when we not only have issues where group policies dictate that the passwords be reset, and also when we finish building the stamp and we hand it over to the customer, we of course know what a lot of those passwords are because we set them when we set it up. When we hand it to you guys, or when you all hand it to your customers, we'll make sure that those passwords get reset. BMCs as well. We have the BMC controllers on the edge servers, on the clusters, on the file servers. We want to provide automation to be able to reset those as well, because you could go to each one by one, and reset the password. Error-prone, tedious tasks. You don't want to do that. You're smiling, right? You don't want to be that guy or gal that's responsible for that. And I'm going to talk to you guys a little bit about the P&U framework as well. It's the patch and update framework that some of the developers that I work with drive. And this is really, let's focus on the business and not on the fabric. When you think about automation, so in the SCOM team for a long time with Daniel and the guys, went over to automation and worked with SMA for quite some time. and then we got pulled over into CPS and we built this solution for you guys. So automation, how many of you folks have used automation? And it's the most wonderful thing, and when you do it right, we love it. It's beautiful. So we'll talk about some of the things we've done. We're going to talk about things like saving time, increasing efficiency, decreasing risk, and decreasing downtime. If I can get the slide to advance. And so I talked a little bit about why automation. I won't bore you guys with the details because I think you all fully understand why automation. Save time, right? You don't want to be the person that has to go one by one, reset passwords, go to the services, bounce the service, make sure the service came up, go to the next one, bounce the service. When you use group managed service accounts as well, native and new to 2012, you want to make sure that those are in sync as well. Increase efficiency, right? You don't need to go through and do these one by one. You can focus on the business, not on the fabric. Decrease risk, right? How many of you all have ever fat-fingered a password, right? I should ask how many of you have never done that, right? You all have. I have. Decrease downtime, right? When you do automation and you implement it properly, you decrease not only your risk, but the downtime as well for those services. So let's talk about some of the operational tasks that we did in CPS. So we talked just briefly, and I'll get into more details and show you all a video demo of that actually in progress. So shout out to Effie who couldn't be here today. She was responsible for these features. Service account password reset, again, for all the System Center, Windows Azure Pack, ADFS, SQL instances, right? It's a lot of service accounts, right? Especially when you look at an instance like CPS, where you have 72 physical nodes, right? 96 virtual instances, right? It's a ton of passwords that you need to reset. The BMC password reset, again, save time, work on something else, right? Be able to run this script, decrease your risk, and most importantly, make sure that the passwords get reset properly. So when you hand those things off to your customers, you know that they have, that the password's been reset. And data consistency, right? We use DPM to do backups of those VMs. If you back up a VM and then the passwords get reset, right, you've got out-of-sync passwords. So to make sure that that doesn't cause an issue, we've given you this password reset script as well. So let's talk a little bit now about password reset. Let me just iterate through all the challenges and the features so you all have a chance to read that. So we talked a little bit about the challenge, right? There's 34 passwords that need to get reset, right? The separation of privilege requires that you actually have that implemented. You could have the domain policies, right? You have a GPO that might get dropped down that says, like in Microsoft, we have domain policies that require us to reset our Redmond passwords every 72 days or every 90 days or whatever it is. It's one of those things you go, oh, God, I got to reset my password. But we want to do that for you. So we implemented the feature that allows you to do this automation. And it does it pretty intelligently as well, right? We want to make sure that we enumerate what dependencies we need in order for this to run properly. Things like the SQL Server. Of course, SMA, right? Service Management Automation. It needs to be alive and running because we've implemented it as workflows, right? And we need to make sure that the services that we are going to reset are available as well. And so there's a slide coming up that will actually walk you through the process of validating that the dependent services are available, validating that the services that you want to reset the passwords on are available, and you can terminate the script, right, when you get to those points where it says, hey, SQL Server may not be available at the moment for whatever reason, right? You can terminate the script at that point. Hey, by the way, I'm going to reset the VMM account, the service account, on the active and passive nodes. The passive node isn't available. Do you want to go ahead and pause? Let's go fix that before we actually run the reset. So we've implemented that. And we've implemented it in a way that we actually use PowerShell and SMA runbooks. So that was the challenge. So here's that process. I'm going to do my best to forward through this without going to the next slide. And you all don't have to read this as fast as I click through it. But I want to show you exactly what we have here. So we talked about the credential input, right? You're going to run this as an elevated account, right? Because you're going to go through, this is something that, this is about as elevated as it gets, right, as far as privilege. So the first thing the script is going to ask you is, who are you, and make sure that you have the privilege to run this account. It's going to enumerate a health check, right? So think about these things as like a pre-flight check. Let's make sure that we're all healthy and we're good, and the dependent services that we need to perform this script and perform its functions properly are available. Again, we'll terminate if the three primary aren't available, SMA, SQL, VMM. Everything checks will go through. If a service that we want to reset, again, is not available, we have an opportunity to go remediate. Password reset starts. We have the password reset in a specific order to ensure high availability, right? This is a very specific order that we worked with all of these teams to make sure that we did it properly. We log as well, so if something should go wrong, it's a very verbose output that's human or machine readable that we can go through and iterate to find out what's going on. And then we tell you what runbooks were responsible for it, and then we'll save the logs into the SMA database as well, just for future reference. So that's what the process looks like. I know that slide is a bit to consume, but just know that we've walked through the right steps to make sure it's done properly. So let's look at the password reset demo. And I think I should... Let's hope this thing just runs. Nope. Let me go back one. There we go. So we're going to invoke the script, provide credentials. How many of you have not seen PowerShell output progress? Nobody raise their hand. This is probably the most exciting video you'll see all week. Right? So again, this will walk through the process that we just talked about kind of in that snake diagram. Let's make sure everything's healthy. Let's validate the components required in order to run this or up and running. Let's make sure that the services that we're actually going to reset are available to be reset. We're going to reset the password. We're going to bounce those services. We're going to log it while we're doing it. And when we're done, we're going to give you a nice report that says completed, failed, go check this, go check that, right? Hopefully it's all completed, you're done. And this is a good handoff, right? When we set the stamp up and we give it to the customer, right? Of course, we know what the default passwords are. Give it to the customer, walk away, it's been reset, enjoy. And this isn't too much longer, but you can see we're going through, we're going to go into SCOM, right? We're going to set the config service, right? The health service. We're going to go into SQL and set the SQL service password and bounce the service. We're going to talk to all the Windows Azure Pack services, right? ADFS tier, the proxy tier, the public API tier. Reset all those passwords. I think there's 34 of them that we actually enumerate through. So those are the run books. Those are the jobs. You will absolutely see completed on the right when it's done. The next thing the video goes through is just shows you where the logs are at. And we could have run this live, but I wanted to make sure we would probably at least run it after Daniel was done with his presentation and before Thomas did his backup in DR Disaster Code. It runs quick. I think, well, how long does it take to run, Daniel? It's this, 17 minutes. So this thing used to take about a day and a half, right, for one person to do it. And those are the kind of jobs and tasks that we would always give to the new person, right? But now the new person gets to run this nice script that walks it through. All right, I'm not going to put you guys through any more of this. I'm going to fast forward. So let's talk about the BMC password reset. Very similar in nature. Here's the script itself. And again, we've got the baseboard management controllers, right, on all the compute cluster nodes, on all the storage nodes, and the edge nodes. And the edge nodes are the ones that are responsible for tenants actually coming into the stamp. So we'll run the PS1. And this shows us, hey, we've got password X across all the BMC controllers in the stamp. We want to change it to password Y. Provide those passwords, run the script, and it does its thing. And again, focus on the business, right? Let's not focus on these fabric tasks And we'll get into that quite a bit more when we talk about the patch and update mechanism, the framework that we've developed specifically for CPS. So you see it's doing its thing on the compute management and edge nodes. Get a nice output. Here's what we've done. Thank you, sir. Drive through. And we're done. Does the logging. So again, real quick, the value prop. Let's do this. Let's provide it to you guys so you can focus on your business and not the fabric, right? Automatically rotate these passwords, make it secure. Saves you time, right? It's more efficient to do it this way. Less error prone, less risk, less chance for someone to fat finger the password or not have a service come up because you've got passwords out of sync. And it's also good for the data recovery as well, right? When you have a password on a service account that may have been backed up and restored, right? Those will stay in sync. And then the big one there is no tenant downtime, right? So no tenant downtime is actually a really good segue into the patch and update framework. I'll refer to it as P&U or patch and update or patch or whatever you guys want to call it. So we've developed this framework to make sure that when we release updates for any of the software components on the stamp, bottom line is we're going to give you a PowerShell script. You need two things. You need an account that's elevated, and you need a right or left hand in order to right-click a PowerShell script and run it. Right? We don't have any dependencies for anything that doesn't live off the stamp. Right? Everything that you need, we absolutely support the disconnected scenario or the submarine scenario, and we do everything for you from validating the patches that go out to orchestrating the implementation of those patches across all of the 96 virtual and 72 physical nodes on a stamp. And we do it with one main purpose. Keep you safe, keep you secure, keep you performant, right? Hot fixes for CPS, critical security updates for Windows Server. But the cornerstone there is no tenant downtime. We don't need to negotiate maintenance windows with your tenants, right? P&U is going to run in the background and the tenant just does his or her thing on the VMs that you've given them to, right? As some central IT admin, I've given the brakes division 1,000 VMs. I've given paint 1,000 VMs. I've given airbags 1,000 VM, right? They've stood up their own workloads. They're running the first-party workloads. They're running Exchange. They're running Link. They're running their own HR web application, right? They will never know that the fabric is currently getting serviced, right? And I'll talk to more gory details about what we're going to do and how we've solved this problem. But let me just talk to you guys about some of the problems if I haven't covered them already, right? Who's done patching for the servers that you guys own? You love it, right? You hate it, right? And I'm proud to say that I own one of the most hated featured problem spaces that Microsoft has today, right? It's a big problem. We wanted to solve it. So it's an error-prone, tedious task, right? How many tools do you have on average? Just throw out some numbers. 1, 2, 30? No, I'm just kidding. Right, it's a tedious task. No one likes to do it. Disruption of tenant workloads, is that ever good for business? Right? When you get those calls to say, hey, Justin, man, I was just working on I had a four-node Exchange cluster and all my mailboxes on node 2. They're all gone. Like, oh, man, you don't want to get that call. Multiple complex tools and processes, right? How many of you have a process in place where you want to do QA on Windows security updates or Windows updates, right, that come out on Patch Tuesday, System Center update roll-ups, SQL cumulative updates, right? Do you all just install those and keep your fingers crossed? I'd love for you to get to that point, and we'll get there. But today, right, it's a safe bet typically to do those in a test environment, right, QA environment. Well, we do that for you. We will never put an update into a P&U package that disrupts your fabric or workloads, right? We have engineering racks, so the hypervisor team has an engineering rack, the spaces team has a rack, the storage team has a rack, right? The protocols team has a rack. They will actually run updates, the P&U packages, as we release them on their engineering racks. Once they graduate from the engineering racks, we deploy them on our internal Nebula racks. And these Nebula racks are running anywhere from 22 to 25,000 virtual machines at any given point. And we'll install those and make sure that we don't disrupt tenant workloads. Only at that point does my team sign the package and hand it out to customers. Right? So you can rest assured that we won't distribute any updates. And these are updates for anything, right? Windows Server, System Center, Windows Azure Pack, security, right? Limited distribution releases, general distribution releases, cumulative updates, update roll-ups, right? Hot fixes, all the above. And the last point there is wasted time, right? I need to go to here to get this update. I need to go to there to get this update. Is the 1.1 the right version? Do I have to install 1.0 first? Right? What's the order? Are they truly cumulative? Do I need a prerequisite? Where do I get that prerequisite? Aside from disrupting your workloads, right? Can I then install, once I've gathered everything, can I install them in an order that doesn't disrupt my workloads? So what did we build? We built this P&U thing. It provides the automated process, right? And so again, all you'll need is an elevated privilege, right? And a right hand to click the PS1 file and run it. And we do a couple things, right? The second bullet there, the first one, simple single tool. We don't have any dependencies that don't live on the stamp. We have a dependency on WSUS because the payload that we build, we inject those updates into the local managed WSUS instance, right? Because WSUS may not be connected outbound, right? We want to make sure that we first and foremost support the disconnected scenario. Literal submarine scenarios, if you will. And so everything that the customer needs to install a P&U package is in that self-extracting P&U package itself. Right? You download, and these things typically range in size from 0.5 gig to 2.5 gigs. And that's really depending on the payload, right? If you have a bunch of Windows updates, if you have a bunch of System Center updates, right, that package will get a little bigger because it's all, again, self-inclusive, right? We take a dependency on the failover clustering manager module, the Active Directory module, right, because we want to build our server maps and figure out what's what, and we update the clusters. But again, nothing that doesn't live on the stamp already. So the second bullet there, fingerprint, right? The most important thing, or one of the most important things you need to consider when you're doing an update of your stamp is, man, what do I have? What is my, when I say I'm going to update my real estate, well, what is my real estate consist of? Right? So we do full inventory. What services are running? What KBs are currently installed? We even take full inventory of the BIOS, the network cards, the JBODs, the EMM enclosures, right? We take full inventory of the hardware as well because the utopia that I want to see us get to, and we have a lot of this fundamental work already, is, hey, we've just done an inventory of your stamp. And we've determined that you're missing KB 123456 on your domain controllers. We've noticed that your LSI driver on your compute nodes is 1 rev back. And we've noticed that your management pack for SQL Server is higher than it should be, right? Because you got an email from your brother-in-law that says, hey, man, you got to try this latest SQL MP and install it, right? So we not only detect things that shouldn't be there, but things that should be there, right? Maybe you get a notification in Daniel's OM, right? SCOM, I love it, was on that team for a long time, that says, hey, by the way, those are the 3 things that I've noticed a drift for. I would love then to get an alert that says, I can run P&U on this, do the update. It'll take about 2.5 hours. I see you've got a maintenance window coming up next Tuesday. You want me to run it then? Go. And it just does it. Because again, we don't need to concern ourselves with maintenance windows necessarily because it's transparent to the user. User doesn't know that it's running. So pre-validated, we talked a little bit about that. I won't go into that again. But just know that we've pre-validated these updates, right? Not only on the engineering racks that each of the team zones that's responsible for how CPS is composed, but also the Nebula rack, which is, we treat them just like a customer because they are one of our customers. They happen to have Microsoft badges, right? But they're running real production workloads for the Office team, for the DevDiv team, right? For the Spaces team. Validates, so the 4th bullet there is one of the interesting ones as well. We're not only going to do the inventory of the stamp, we're going to do the update of the stamp, But before we add an instance back into the layer, we're going to do some validations on that service to make sure that we didn't break anything. Maybe there's something we didn't catch. Maybe the update process, maybe that MSI was broken or that MSU was broken or didn't do exactly what it was supposed to do. Right? So when you think about checks, on a domain controller, after we service one of the DCs, Daniel talked about the DCs. We have 3 of them. They're all global catalogs. They're pinned to specific hosts. Right? When that DC comes back up after it's been serviced, maybe do a simple LDAP query. Right? DNS is running, so let's check port 53. Right? SMA, let's enumerate our runbooks. Right? SCOM, let's enumerate our management packs and get alerts. Make a simple call into the SDK to get our alerts. Right? Same thing for WAP. Let's do some fundamental checks against WAP to make sure that it's healthy before we add it to the layer. Because what we're going to do, we're going to pull a WAP instance, for example, from behind the load balancer, service it, add it back to the layer. But before we add it back, we're going to do those validations. And all the while, before we start servicing that instance, whether it be a virtual instance or a cluster node or a physical node, we're going to enter maintenance mode, right, in SCOM, do everything that we need to do, update, validate, return, and then exit maintenance mode on our way out. Right? And that's important just so, as Daniel talked about, no alerts that aren't actionable. Don't wake me up at 3 a.m. to tell me that, one of my 72 cluster nodes is offline, or a resource is offline. Right? Don't wake me up for that. That'll fix itself. Designed to support the submarine scenario, right? We want to make sure that we operate in a disconnected scenario, right? Everything you need, I know I've talked about beat this dead horse, but everything that you need in a PNU package to do the update is in that package, right? And they range from 0.5 gig to 2.5. And the runs usually take anywhere from 15 to 18 hours. And it's really dependent on 2 things, right? Payload. If I've got 40 updates in that package, right, it's going to take a little longer to run than if I have 2. And workload. If I've got 500 VMs running on each compute cluster node and I need to live migrate 500 VMs 2 by 2, well, that's going to take a little time, right? Because we do it safely, and we do it slowly, and we do it in a way, again, that doesn't disrupt those workloads. But say, oh, man, Justin, 15, 18 hours. If you're not disrupting your tenants or your customers, does it matter? I hope it doesn't matter to you guys. I hope you guys agree with me on that. So negotiating those maintenance windows is not something we need to concern ourselves with. Production ready, update, release cadence. We've released update 1, and we're working on an update 1.1. Well, what does that mean? That's not a major update. We have the ability to build monthly updates as well. And we do this because you can bet, I don't know if you're gambling folks, but if you were, you'd say that there's probably going to be at least 1 critical security updates that come out on a Patch Tuesday, the 2nd Tuesday of every month. And so our team actually looks at those and evaluates each one by one with our response, MSRC, our Microsoft Security Response Center. And we say, hey, is CPS, what's our exposure for this one? And they go, oh, are you running blah, blah, blah? We go, nope, well, you're not exposed. Skip that one. Hey, what about this next one? Oh, are you running XYZ? Yeah, we are. You're absolutely exposed to this one. We will never leave our customers in a state where they are unable to apply a security update. So we'll build those monthly packages, and we just do major dot minor builds. Update 2, I think VJ talked about that later this fall. We can add features in our update, our major packages as well. So think about the release cadence, right? We have some customers that say, hey, Justin, after 24 hours after a security update lands on CERT as a CERT advisory, we start kicking nodes off the network. Right? So we need to support those folks as well. It's kind of our lowest common denominator. The last bullet, the sequencing and dependency aware. Understanding the inter and intra dependencies that exist in a CPS stamp to ensure you don't disrupt your workloads, man, it took me a long time in my team to figure that one out. And we did. But when you think about things like the Windows Azure Pack, right, there are 2 VMs for each of the 3 tiers for the tenant inbound. There are 2 VMs, I call them twin sisters, or they could be twin brothers, right, for each of the tiers that actually enter for the management stack. You've got half of those running on the compute cluster. You've got the other half running on the management cluster, right? Understanding that we need to update SPF and VMM before we update the Windows Azure Pack, right? We need to do that. Updating the Windows Azure Pack in a very specific order as to avoid tenant inbound disruption or the API tier, the proxy tier, right? Very important to understand. So let me show you what that looks like. I didn't make this up. This is absolutely for real. If you look, and my eyes aren't as good as they used to be, each of these tiers actually has a number by it. And you'll see the number just to the left of it. You need to update, and we as the P&U team update each of these tiers in that order after we've updated the white boxes, right? The VMM and the SPF services, right? And you've got your resource providers down at the bottom. You can see the management control layer, right, for the management functions in the WAP port exist on the management cluster, right? In the compute cluster, where the actual tenant VMs live that get created through the WAP portal, live on the compute nodes, right? And so there's a very specific order that we need to adhere to make sure that we don't disrupt the workloads, right? And that's literally what it looks like. So we talked about what to leave in, what to leave out. We've implemented a scoring system. And this is just a fancy way to say that we review each update and determine its applicability on a CPS rack, right? So when you think about all the different workloads that we have and all the different, how many of you would like to see Microsoft come up with one patch mechanism, right? One extension, right? Because how many do we have, right? MSUs from Windows servers, MSPs from System Center, MSIs from Windows Azure Pack, old school EXEs for cumulative updates for SQL Server, right? Some publish to move, some don't, right? So it's kind of hard to figure out, going back to my slide earlier, where are these things? Where can I get them? How do I know which is the latest one? So what we've done is we've built a system and we've put a scoring system in place to say, hey, like we were talking about earlier, we weren't having a discussion, but I was pointing at you. When we talk about security updates that come out, is it critical? What's our exposure? Is CPS exposed to this update? Well, it is. Well, it gets a 3 automatically, so it needs to go into the next minor update, right? And these packages are cumulative as well, so you can go from 1 to 2 and know that you get the benefit from 1, right? And the last bullet there, we absolutely have these major updates that come out quarterly, but we'll have the minor updates as well as needed for security as we need them, right? And that's just the smart thing to do, right? We don't ever want to leave our customers exposed. Additional benefits. We've got a faster cadence, right? We can turn these things around. We can crank these updates out. We can build these P&U packages. We don't want you, and we would advise you not to, if you can do me that favor, do the updates on your own, right? Right-click the PowerShell script, download the packages, right-click the scripts, go get a cup of coffee, actually come back the next day, and it'll be done. Increased reliability, right? We've got a controlled process. We've got a pre-validated patch bundles. And we will halt, I call them courtesy halts, right? We've had instances, and how many of you guys have ever been on the receiving end of the call of, man, I didn't touch it. I came in this morning, it was like that. You all have done that, and you guys have also been on the receiving end of that, I'm sure, right? So we want to make sure that if someone deletes the SCOM agent from an instance, or if someone changes the ACL on a share, or someone stops a VMM service, right? And there's all kinds of good reasons why these things happen. There's a lot of bad reasons why these things happen, right? But P&U will actually halt if it finds something that it should terminate about, and give the user the opportunity to address that issue before we continue. Simpler validation metrics, right? We know exactly what is on a CPS stamp because we built it. We know exactly what's on a P&U package that gets deployed and updated on a customer stamp, again, because we built them. And so from an issue of, hey, we need to try and repro this issue, right? It's a lot easier for us. You know, tip of the hat to Jimmy over there who's busy on his keyboard, but he gets it, right? It's a lot easier for our support folks in CSS because when you buy CPS and you have an issue with CPS, You don't call anybody but us. It doesn't matter if it's hardware, it doesn't matter if it's software, it doesn't matter, right? We're one vendor and you call us about it, right? And we'll take care of it. Limited set of possible configurations, right? You don't need to tweak the storage, right? You don't need to tweak these management packs, right? You don't need to tweak the ACLs on anything. You don't need to apply group policies to these things. Improved customer support service. I think we talked about that, right? We've got some really good verbose logging, and we've got some detailed logging as well. So if something goes wrong, you will absolutely be set with logging. Here's what that looks like. I won't bore you guys because we talked about the update process. You know, we go through, we validate, we do the inventory, we do the update, we enter maintenance mode, we service the object, we take the service from behind the load balancer, service it, add it back, evacuate maintenance mode, and go to the next thing. Live migrating, right? VMs, cluster we're updating, right? VMM service templates are getting hooked with our own custom resource to actually do the updating for those services that were deployed with VMM service templates, right? Again, all orchestrated. Focus on the business, not on your fabric. With that, I'll turn it over to my friend Thomas to talk about backup and disaster recovery.
Can you hear me okay? Great. Before I dive into backup and disaster recovery, I want to raise a quick question. How many of you are not using Data Protection Manager for backing up their workloads? Don't be shy. Okay. So for CPS, the product that we're going to use for backing up is Data Protection Manager. Hopefully it's not going to be a surprise. I'm also going to talk about disaster recovery. We're using a product there that is called Azure Site Recovery. And I'm going to walk you through what we have done to operate backup and disaster recovery at a scale of CPS. When you think about the scale of CPS, Daniel called it out in the beginning. When you think about all the resources that are just in a single rack, and if it expands to 4 racks, what we have tested, right, is a capacity of a maximum of like at least 2,000 VMs per rack. Now, when you think about in a full STAM, up to 8,000 VMs, this is the scale where backup needs to operate. And at the same time, I need to be able to manage that. So I'm going to walk you through what we have done to make the operation of backup really feasible, and how to also look into recovery to keep recovery consistent. So when we started planning of CPS, we actually had 2 scenarios in mind. The first one was, as a service provider, I can back up the management cluster and provide backup as a service to my tenants to protect the tenant workload. That has been the main scenario. The second one, and there's a good session tomorrow about the architecture that dives deep into the storage stack of CPS, is as a service provider, I can optimize my backup storage by using backup deduplication. Again, one thing I want to call out here is actually, and I think Vijay mentioned that in his session yesterday, a common question that we get very often, is there any specific software in CPS? The answer is always no. It's the products that you use today. And a lot of the evolutions, experiences that we have gathered as part of building CPS, and one of them is actually deduplication for DPM. I don't know for how many of you have seen the white paper on DPM to enable deduplication. So that is a learning that came out of CPS. So this is a slide that actually I want you to focus on the management cluster, and Daniel did a great job walking you through the component of the management cluster. What I'm going to do is basically lay down the technologies that we use for backing up that management cluster, and then we focus on the tenant side. I think the first thing that I want to call out actually is when CPS arrives at your data center, backup is ready to go. We have made the thoughts about when to schedule the various backup jobs for databases, Active Directory, to really ensure that nothing is overlapping. Daniel talked about Active Directory stored on local disks. It's not using the cluster. When you think about backup, Data Protection Manager relies on SQL Server. If Active Directory is down, I cannot bring up SQL Server. So how do I back up my Active Directory? So we switched using Windows Server Backup for backing up our Active Directory. What that leads to is our Active Directory domain controllers have additional disks where we store the system state backups. For SQL Server, we're doing in-gas backup. What that means is actually the DPM protection agent gets installed inside the SQL Server, and we're doing in-gas backup of the SQL databases. And if you look across the components, what you notice actually is that the majority of those components are relying on a SQL database. And what that challenge brings with it in a resource scenario, I'm going to talk later about. For all the VMs, VM objects, SPF, VMM, we're doing host-level backup, so we're backing up the entire VM as a container. I want to dive into the schedule and the retention date so that you get a feel what we have done here. As I said in the beginning, we have made those thoughts, right? How are we going to back up? When we're going to back up? How long do we keep the data to not exhaust our storage that we have available? So when you think on a VM base, right? So all the VM objects, they're going to basically back up once a week, and we keep them for 2 weeks. Databases, we back them up through a Express full backup every 4 hours. And we keep them for 5 days. Active Directory is going to be backed up once a day, and we keep those for 5 days. How does it look on the tenant side? So on the tenant side, actually, we need a lot of coordination. Why is that? When you think about the scale that I mentioned before, we tested up to 2,000 VMs per rack. So that means actually we're deploying multiple Data Protection Manager instances to be able to protect that amount of VMs. In detail, we're deploying 8 instances of Data Protection Manager. And when you divide that, obviously, by 2,000, we're ending up with 250 VMs per Data Protection Manager instance. So now the challenge actually is, how do you coordinate and manage the distribution of all those VMs across those 8 DPM instances per rack? And the answer is automation. So we have taken care, and I'm going to show you later in the quick demo, how that runbook looks like that we have developed. So for the tenant VM protection, when you think about the schedule, it's not really a schedule, it's more like the backup window that you see here on top. So the backup window is actually from 10 p.m. to 6 a.m. in the morning. Virtual Machine Manager has a library where all the content is stored for your tenants, gallery items, VHDs, ISO images. So we're backing that up as well. What we leave up to the administrator actually is to schedule how often we should run that automation job to really detect newly provisioned VMs and distribute them across protection groups. So that is really that we leave up to the administrator to say, should he run once a day, twice a day, once a week? It's really up to the usage scenarios that you have. I want to do one step back here onto this slide for a specific reason. You have heard about CPS comes with an F5 hardware load balancer. And you may actually raise the question here, hang on, CPS is a pre-integrated solution. What about the network switches? What about that configuration? Is that back up too? The answer is yes. It's not done by DPM. It's actually done by a tool that is called the Dell Active Fabric Manager. So Dell Active Fabric Manager takes a regular backup of the configuration of the switches. And that VM actually, so Active Fabric Manager, lives in a VM and is actually backed up by DPM as well. For the load balancer configuration, what we do actually is, again, we're having a runbook that backs up the F5 configuration on a daily basis. I talked about deduplication, and I want to throw in some numbers here to give you a feel for that storage, what we're doing on the storage side for the second scenario. CPS is built on storage spaces. What we do is we're creating 3 storage pools, and I have thrown in here a couple of numbers. It's just for your reference. What I want to call out is actually what is important to see is that the total available space from that storage pool for backup is 115 terabytes. Sorry. And each DPM server gets 20 VHDs, each a terabyte. So when you multiply that by 8, you're going to see that the required storage is 160 terabyte. So that's obviously more than that is available. So how are we gonna solve that? The answer is we have deduplication enabled on those pools. So we're saving up to 45 terabytes for placing those backups. The biggest challenge actually is recovery. I talked about that in the beginning, said we're having a lot of database dependencies. So there's a scenario that I want to walk you through that we solved actually is imagine in CPS we have Windows Server, System Center, and the Windows Azure Pack. So now let's assume your VMM database got a corruption. Windows Azure Pack is still up and running. You can still have tenants coming in, signing up for a service. So that user gets created in the Windows Azure Pack database, but the user is not synced through SPF into VMM. So when you restore that VMM database, that user is not there. That means there is an inconsistency. And you have that challenge all the time when you have multiple databases and how they're getting restored. So what we have done again is we created a runbook, a data consistency runbook, that specifically detects those inconsistencies. It tries to fix it. If not, it will at least call you out and say, hey, there is an inconsistency. I was not able to fix it automatically, but you are aware of that inconsistency. We talk to customers and we work very closely with customers, and what customers told us very clearly is we need to be able to, basically they said, hey, this is great that you have stored the backup on your local rack. But if that room dies where I have the rack located, I can't recover from backup. So they want off-stamp backup, and guess what? We agreed. We need off-stamp backup. So for those of you that have worked with DPM, there is a scenario in DPM for primary and secondary server. So it is a solution that we have enabled to really be able to store the management cluster and the tenant VMs in a primary and secondary DPM scenario that you're going to see coming in update 2. And that secondary DPM server can be located either at the same location or in another location. Actually, I want to do here a quick demo looking at the time. I'll do this pretty quickly. Yes. Let's see, this is still up from Daniel. I'm doing a quick refresh here, see if the errors came up here. Because as he told you, I was responsible for other errors that you can see here in OM. That's the one that Daniel shut down. You can see that a WAM alert came up, right? Just took a while. So what I'm going to show you very quickly is, just because we have a WAM open here already, as Daniel called out, I'm responsible for creating the little mess in Operations Manager. So on purpose, I have broken the backup for a couple of tenant VMs to really show you that if a backup fails, if a VM misses the SLA, that it couldn't be backed up in that time window that I showed you, from 10 p.m. to 6 a.m. in the morning, we're getting an SLA warning in Operations Manager. So it's also fully managed or fully monitored by Operations Manager. What I'm going to quickly show you actually is the Windows Azure Pack Admin Portal, and I'm showing you service management automation. I want to quickly show you the runbook that actually is available as part of CPS, that is going through all compute cluster nodes. It's looking if a VM is already protected. If not, it will add it to a protection group. What it actually does is it first queries which is the DPM server that is backing up the least amount of VMs, and is adding that VM to that specific DPM server as a protection group. So in Windows Azure Pack, you have automation, you have runbooks, and what we ship with in CPS is actually the runbook to protect the tenant VMs. There we go. That's the runbook. As you can see, we have it not scheduled right now, given that this is demoed out of the racks that are in the expo area. There's one more runbook that I want to make sure I've mentioned it, that actually allows you to exclude VMs on patterns. What that actually means is that if you have a customer or you don't want to back up specific VMs, you can just exclude them with the runbook actually. As I talked before, disaster recovery is built into CPS, so we're leveraging Azure Site Recovery. And we're providing two options. The one that is currently available is what we call E2E, enterprise to enterprise. And that basically allows you to replicate virtual machines between two individual stamps. With Update 2, customers told us very clearly, hey, my CAPEX and OPEX, I want to be able to replicate to Azure, right? I don't want to buy a second stamp, operate a second stamp that sits there passive just for the disaster recovery option. So I want to replicate to Azure. And that's exactly the scenario that we're going to enable with Update 2. This is the E2E scenario, two CPS stamps. Replication goes between the two stamps on your network. Orchestration lives in Azure. So you can basically build or you can fail over complex services, build dependencies between services. I'm going to skip the demo for time purposes and show you last the DR to Azure that actually enables a scenario that is already available today outside of CPS, and it will be coming with CPS Update 2. That you can replicate to Azure. And with that, I hand it back to Daniel.
Thanks, Thomas. Appreciate it. Am I on? All right, we're running. We have a minute left. So went through a lot of there. If you want to see the DR demo, come by the booth. I'm sure Thomas can kind of show you that, take you through that there. That's a lot of complexity we showed you there. I think the key takeaways I want to leave is that the complexity we're showing you is in terms of kind of how we've configured the system. So when you get that, these things are taken care of. Right? You don't have to worry about how do I configure my monitoring, what am I going to do about patching, what am I going to do about backup and disaster recovery. We've learned from the system, from running it internally, and we've provided you with so it can be plugged in so you get on with the business of running your private cloud. And you should have minimal interaction on a daily basis with the stamp when it's running. So we really kind of want to show, how that total cost of ownership from once you own it and running it on a daily basis is the lowest of any Microsoft Cloud solution. So that's what we have. As put in the site, I don't know, there's an Ignite Azure challenge going on. You take this code, the sweepstakes, to win a load of stuff. With that, since we're out of time, we'll take questions kind of at the back, as there's probably another speaker coming in. But I really appreciate your time this morning. Thank you.